Hello everyone, welcome to course study on solid mechanics. In today's lecture we are going to start a new unit, that is unit number 6, axially and eccentrically loaded column. Okay, so in this particular unit a column is subjected to axial load as well as the eccentric load, and that we are going to discuss in detail. So first of all we will discuss the introductory part of this particular unit. So remember that the structures and the machine may fail in varieties of ways depending upon the materials, kind of load and the condition of the support. This failure can be avoided by designing the members so that the maximum stresses which are developed into the material will remain well within the tolerance limit. Okay, so as per the given statement, the structural element, the machine element may fail in varieties of way depending upon the material of which it is made. Okay, the kind of load or the type of load to which it is subjected, and the very important one is the type of the support, whether it is pin support, whether it is fixed support, whether it is hinge support. Okay, so the failure of that particular structural element or the machine element, it depends upon the material, the kind of load to which it is subjected and the condition of the support. Okay, this failure can be avoided by designing the members so that the maximum stresses will remain the well within the tolerance limit. Okay, if you have to avoid the failure of those material, okay, so we have to design it in such a manner that the stresses will remain well within the permissible limit or well within the tolerance limit. Okay, so first of all we will discuss the definition of column. What is column? Column is nothing but it is a vertical structural member carrying an axial compressive load. Okay, its length is long as compared to its other two dimension. Okay, so column is nothing but it is a vertical structural element which is subjected to axial compressive load. Okay, and for the column its length is greater than the its lateral dimension, that is length is greater than its width and height. Okay, so it can be considered as a column. Okay, the example of column which is subjected to a compressive load is column in RCC building, or strut is also a compressive member which is used in the truss, which is used in the mechanism. Okay, so from this particular figure we can see that this is the first figure. In this particular figure a column, vertical column is shown which has a length L, and it is subjected to a compressive load of axial compressive load of P. Okay, due to that particular column it is under the action of compressive load, it is under the action of compressive force. Okay, the second figure shows a truss mechanism. In that particular case the weight of the house roof is acting over here. Okay, and that particular weight it get transferred through the strut in this manner. Okay, and that particular strut it is under the action of compression, because this particular brick, this particular support, it offers the reactions to that particular strut. Okay, so strut is also a compressive member which is subjected to axial compressive stresses. Okay, so this is the example of column. Now we will discuss the different definition which are related to unit number 6, that is for the column. So first of all we will discuss the crushing load. What does it mean? Crushing load, it is a load at which the members fail by crushing only. The name itself indicates what is crushing load. The members fail by crushing only. There will be the crushing of member. Okay, and the load at which it fails, the load at which it crushed, that load is known as the crushing load. Okay, next one is crippling load, which is also known as buckling load or the critical load. So the name itself indicate again what is crippling load or the buckling load. Okay, it is the maximum load at which the column tends to buckle laterally. It is a load at which the column tends to buckle laterally. For example, suppose this is a vertical column. Okay, it is subjected to a compressive load. Okay, if I go on increasing the load, at one point what will happen, there will be the buckling of that particular column in this manner. There will be the buckling of that particular column in this manner. Okay, so it is a load at which column tends to buckle laterally in this manner. So that load is known as a crippling load or buckling load or the critical load. Okay, a note is given regarding the crippling load or the buckling load. The buckling always takes place about the axis which have a minimum radius of gyration. So remember that the buckling of column, it always takes place with the axis which has the minimum radius of gyration or which has the least moment of inertia. The axis which has least moment of inertia, smallest moment of inertia, about that axis the buckling take place. Okay, now the next definition is safe load. It is a load to which column is actually subjected and is well below the buckling load, then it is known as a safe load. So safe load is nothing but to which the column is actually subjected, and that load must be less than the buckling load, because at the buckling load the column tends to buckle laterally. So whatever the load we will apply, that must be below the buckling load to avoid the crippling or buckling of that particular column. Okay, and mathematically safe load can be given by safe load is equal to buckling load upon factor of safety. Safe load is equal to buckling load upon factor of safety. Okay, so the concept of factor of safety we have already discussed in unit number 5, and in case of theories of failure we have come across the definition of factor of safety. Okay, now next topic is types of column. So there are three classification of column depending upon the slenderness ratio. So the slenderness ratio, the column are classified into first one long column, short column and the intermediate column. So first of all we will discuss the long column. For long column, slenderness ratio is greater than 12. For long column, slenderness ratio is greater than 12, and mathematically the slenderness ratio can be given by, it is a ratio of effective length to the least lateral dimension. Mathematically, slenderness ratio can be given by the ratio of effective length to the least lateral dimension, and that must be greater than 12. Then it can be classified as a long column. So what is effective length, what is least lateral dimension, that we are going to discuss in coming slides. Okay, in case of long column, the column fails due to the action of buckling, therefore the buckling stresses are greater than the crushing stress, and hence the crushing stresses can be neglected. So for the long column, as its length is greater than the other two cross-sectional dimension, so the failure of the column take place due to the buckling instead of the crushing. Okay, so as the buckling stresses are greater than the crushing stresses, so we can neglect the value of crushing stresses while calculating or while solving the numerical. Okay, so we are not accounting the effect of crushing stresses in case of long column. Remember that for long column the buckling stresses are always greater than the crushing stresses. Okay, now next definition is short column. For the short column, slenderness ratio is less than 12. Okay, and mathematically it can be given by, it is the ratio of effective length to the least lateral dimension which is less than 12. Okay, now for the short column, the column failed due to the action of crushing. Therefore, crushing stresses are greater than the buckling stresses, and hence buckling stresses can be neglected. Now it is converse to the long column. In case of short column, the failure take place due to the crushing instead of buckling. Okay, so it means that the crushing stresses are greater than the buckling stresses, so we can neglect the buckling stresses in case of short column. Okay, and the last type of the column is intermediate column. For the intermediate column, the column fails due to the both action, that is buckling as well as the crushing. It is a combination, it is the failure due to the buckling as well as the crushing. Okay, so in intermediate column both the stresses are taken into account, as the failure takes place due to the both So we are accounting the effect of crushing strength as well as the buckling strength. Okay, and now we are going to define effective length. What is effective length? Effective length is the distance between the point of contraflexure. Effective length is the distance between the point of contraflexure, or it is the distance between point of inflection in the deflection curve. Suppose this is a column, okay, and this is the longitudinal axis, and it is subjected to external load P and external load P. If I go on increasing the load, what will happen? The column will bend in this manner about this particular vertical axis. Okay, so the distance between these 2 points, because it is a inflection point, the distance between these 2 points is known as the effective length. Okay, so today we will stop here. In the next lecture we will start the another topic of column. Okay, and that particular topic is equilibrium condition for the column. Okay, so we will stop here. Thank you.